All right, number 11. Now, I hope you're not looking at these videos before you're trying these. Otherwise, you're probably not going to get out of this what you need to get out of. The best thing you can do is to try these, think about them, then come back to the video and listen to me talk about them and see um, if you can fill in what you were missing, which is the reason you're watching the video, because there was something you're missing. Um, okay, so online insurance, after seeing countless commercials claiming one can get cheaper car insurance from an online company. Was that Progressive? Does that drive you crazy? No, Geico's the other one. I don't know. Anyway, um, a local insurance agent was concerned that he might lose some customers. To investigate, he selected profiles for 10 of his clients and checked online price quotes for their policies. So here's the local price, and here's the online price, right? Talk about that. And then the price difference, it says, is the local minus the online, right? Okay, so now, is this one where you'd want to do a paired? Would you want to do a two-sample t-test where this is one sample and this is the other? And why wouldn't you want to do that, I should say? Well, this is client 1, and that's his price for each of them. These are not independent of each other because they're both dependent on the same number of cars he has, the same coverage, and all of that. Okay, so these are not independent, so I cannot do a two-sample test. But if I take the difference between them, now I've got one sample of differences. So mu of the differences, we call it this, mu difference or mu d. Okay, makes sense, right? This is the average difference. And I can do tests, and say, remember, for H0, this is a quick little review, I can do mu difference equals 0, or HA mu difference is not equal to 0, or I could do greater than 0 or less than 0 or something like that. Okay. What I also can do is I could make a confidence interval. And the confidence interval is I'm doing a confidence interval for the average difference. So my sample average difference is d bar. We call it x bars, sometimes, but we do d to talk about that their difference is plus or minus t star times the standard deviation of the difference over the square root of n. All right, that's our normal one. This is a one sample t interval, and it's paired. Okay, so here's the question that they're asking. When I go to find the standard deviation, why don't I do the standard deviation of the local squared plus the standard deviation of the online squared, right? And then take the square root, because this is that what we've done in the past. We've taken the variance of x plus y, or minus y, remember this, equals a variance of x plus the variance of y. And so if I take the square, let me leave it at that, right? I have to add the variances together. So when I square the standard deviation, that's the variance. Okay, this is the standard deviation squared of x plus the standard deviation squared of y, right? And then, of course, to find the standard deviation, I would take the square root of both of those and get standard deviation of x minus y. Okay, so when they do this here, they get this number. But up here, this is the standard deviation. Right there, right? Okay. So why are they different? What is this formula right here used for? This is for finding the standard deviation of the difference of two samples, right? So I've got this sample and this sample. This is to find standard deviation of 2 samples. But I only have one sample. This is just, this right here is a standard deviation of 1 sample. Okay, so they're going to be different. I don't add the standard deviation or, add the variances together or things like that, because I'm not doing 2 separate samples. I'm writing it as 1 sample. Does that make sense? All right, so let's take a look. I think I've got one more here that we can do on this video. 17 is cars and trucks. We have data on cars and trucks. Here's a graph of the difference of what? I don't know what. Let's read it. Would it be appropriate to use paired T methods to compare cars and trucks? We're talking fuel efficiency. I want to compare cars and trucks. So I would say like city. Okay. Could I do, how would I do that? How would I do compare? I'm trying to think here. I want to compare cars and trucks. So could I do, let me write it like this. I've got data on cars, and I've got data on trucks. Are these two somehow related to each other, the cars and the trucks? And the answer is no, because your cars are going to get miles per gallon for the city and highway, and so are the trucks. But I can't. They're not related to each other. They would be independent of each other. I take samples of cars and samples of trucks, right? So I would say no. Okay. Cars and trucks aren't related. Miles per gallons aren't related. And then B, would it be appropriate to use paired T methods to compare city and highway fuel efficiencies of those vehicles? Well, the answer is yes, because I could do city, highway, I could do car 1, car 2, and so forth. And then I've got city and highway, and it would make sense to compare the difference, right, between them. I could do truck 1 and truck 2, right, and I could look at the differences that way. So that's how I would do it. Okay, so C says a histogram of the differences highway minus city is shown. So remember, one of the conditions, it's usually the third condition that we do. Let me just go ahead and do this just to recap. For a paired test, the conditions are the samples are random, the samples are paired, the N is less than 10% of the population, and 4, N has to be bigger than or equal to 30 or bigger than 30, or the population normal, or the sample. Now, we can say nearly normal, unimodal symmetric, no outliers. Is this condition met right here? And that looks really nice, except we have this outlier down here. So since we have this outlier, this condition is not satisfied. Okay, so that's the answer there. Does that make sense? Because remember, we got to have one of these three has to be satisfied. That one, or that one. And we know that's not, and I don't know about the population distribution, and this one is not satisfied. Okay, there you go on that.